Hi everyone, welcome to today's webinar. This time we'll be taking a journey through the process of 3D modeling of vein structure from the raw data through to the final model. Joining me for this session is Mark Williams, a resource geologist on the sales team here at Maptek's UK business. Mark has first-hand experience working as a site resource geologist at the project in focus for today's webinar. So prior to his experience at Maptek, Mark spent 15 years as a greenstone geologist, including extensive experience within the Barberton Greenstone Belt. He'll be taking us through the standard practices and challenges in generating valid 3D models for this type of project. And then he'll take us through a modern approach that exploits new software technology and a repeatable and integrated workflow approach to streamline the modeling process. Now, throughout this webinar, you'll have access to the question and answer facility. So please send us any questions that you have. We'll try to cover them during the Q&A, which is at the end of the webinar. We will try to answer as many questions as we can, but in the event that we miss any, of course, we'll aim to follow up with you privately after the session. For anyone who's joining a little late, if you've just had a bit of delay getting connected, we're just about to start our latest webinar, this time looking at an exciting new approach to 3D vein modeling. So it's time for me to hand over this session to Mark, who's going to take us through the webinar.
Thanks very much. Okay, morning everybody. This morning, I'm going to, as Gary said, we'll take you through sort of a traditional approach to narrowvane modeling, and then look at a more sort of modern way of going about doing it. But I think the overarching theme about this presentation is that it's applicable to both exploration and mine sites and everything that falls in between those two. So very often, as a geologist, you may come into a site that's not 100% greenfields. There's a fair amount of historic data available, and the ability to be able to coordinate and bring all that data in is very important. And I'll have a briefly look at that during the presentation. Right. So if we take a look at the characteristics of narrowvane geology, generally, the problems for geology, for the geologists, is that there's complex geology, the mineral veins and shear zones that are being exploited or look to be exploited. There's variations in continuity, dip, strike, width, or mineralogy, and sometimes even that goes on to affect the metallurgy downstream in the plant. They're composite, so grade and mineralization is restricted into zones, which we'll look at today. They branch, and you get intersections and braided zones, which are common features, and then also ore shoots. So where does data come from? Well, on a greenfields level, we very often will start off a project with geophysics. We've also got underground sampling, soil geochemistry, trenching, one of my favorites, underground drilling, reverse circulation or RC drilling, and then diamond drilling. So if we take a look at a historic workflow, so the way that things would traditionally be done, you would acquire the data through mapping, your geochemistry, geophysics, maybe do a trenching program. You would start off with a drilling program, and then eventually, once you get up and running, underground sampling, etc., would take place. From that data, you're going to develop sections. So generally, or traditionally, it's horizontal sections. But in the case of steep dipping narrowvane deposits, longitudinal sections and level planes or flitch planes, I come from South Africa, as you can hear, so the terminology might not be exactly the same. And those are then used to generate a solid, which we can then use for determining volumes, etc. That information is then interpreted and digitized. So the sections are generally done paper-based, and they're then interpreted and digitized. And then from that, they are then used to generate a wireframe from the sections. So the process of interpretation, or interpreting the data and digitizing, and then generating the wireframe from the sections, is a pretty slow and repetitive process. So it needs to be done regularly. It needs to be kept up to date, but it takes quite a fair amount of your geology resources in terms of time. So these are some traditional examples that I've pulled out. So here is an example of a shear that's splitting or horsetailing into three distinct zones. As you can see, I quite like Sharpies and color pencils. So you color them in, you put your grade, etc. on them. But what's important to note out of this is two things. Firstly, if you take a look in the background, you can see clearly that the actual computer-generated wireframe is quite blocky and chunky and very sort of unorganic. The other thing that's quite important to note out of it is that the shears sort of fade in and then they fade out as you move. So these are 10-meter sections. I'll just flip backwards and forwards. And the shears, there may be data or no data, and you've then got to make an interpretation based on your best geological experience and your knowledge of the ore body. So here's the wireframes from that example. As you can see, as the structure runs up against the dike, on the eastern side over there, it horsetails out into three prominent structures which can be modeled. So there's the main structure, which is in the purple. You've got a hanging wall structure, which is in sort of orangey yellow, burnt orange, and then you've got the green structure, which is a footwall structure. So in each and every single one of these occasions, you've got to generate a set of sections for each one of those areas in order to understand and generate solids for those. And that again goes back to one of the things we spoke about previously, which is the fact that in these zones, the mineralogy or the grade, etc., may change significantly and actually affect the output that comes out the other end that you want to pass on to your mining engineers in order for them to determine whether this is a mineable resource. So it's quite important from a domaining perspective that you're able to separate these bits out, and that is time consuming. Right, the other sort of side effect, and I'm going to just use this one. In our case, Vulcan's pretty good at producing some nice smooth solids, but going back to that sort of chunky look and feel, because the sections have been generated at, let's say, 10-meter intervals, when the surface of the solid is created, it's inclined to produce really chunky results. And that's not always desirable. It's the best at the time, but what we'll be looking at today is looking to improve that. And that's obviously because it's coming from the sections that you've then developed. Right, the other thing that's important to talk about is that very often in your process of collecting your data, you're going to go through quite a rigorous process of determining through sections and through looking at your assay data, your downhole logs, etc., where zones start and finish. And this is an example that I've used in the past on sites that I've worked on. We call this a Reef allocation form. This is not something that's I refer to Reef because, again, in South Africa, mineralized zones are generally referred to as reefs. But you can see here, I'll just zoom in a little bit, that there are two mineralized zones that we're concentrating on. So in the geology, you've got a background shale. And then as you come into the first shear zone, it becomes more quartz-rich. The grade improves. There's a bit of a parting between the two zones, and then there's another zone. So in your natural process that you're going to follow going through the actual collection of your data, your geological data, you're going to have an idea of where data or where these zones start and where they finish, which is quite important because that talks later to how we'll go about modeling that. Right, so if we look at a more streamlined process, you're going to still go through the same traditional geological processes, in that you're going to collect the data, interpret it, look at it, and come up with where you feel that the specific mineralization sits. You're going to then generate a database with from to points in it, and in addition to that, you're going to use mapping strings. So these could be underground mapping, surface mapping, mapping out of trenches, etc., or even potentially geochemistry or geophysics mapping that is going to give you data in order to help you to improve your wireframe or your solid. You're going to run the Narrowvane tool. Automatically, that improves your geological understanding and it gives you something to work with. It allows you to target drilling and potential mapping, so areas where you feel that you're lacking geological understanding. And then you're going to add to the database, add mapping strings, and you're going to run the Narrowvane tool again. Once you've done that sufficiently, you'll have then developed a solid that can be used for developing a resource. I think what's important is that this replaces a very time-consuming process. And it gives you the opportunity to produce faster results at the end of the day, which is quite important. So looking at the results, you can see that using this type of process, we get a much more organic looking result, which is important. Right, so the conclusions from what we're going to look at today, the process is not to replace the geologists. And please, I want to emphasize that. At the end of the day, it doesn't change what you're going to do. You're still going to go through the same processes. But what it does is by automating this process, which is invariably very well checked, very well scrutinized, it's going to save you an astronomical amount of time. It improves your ability or your accuracy. So it allows you to quickly see where there's anomalous data, and you can then go back and check to see if there's a problem. You get a more organic result. It speeds up the results to your management team, which in turn to investors and to the market. And obviously good news on the marketplace means that people are confident in investing in your exploration or mining company. And it provides engineers and miners with a clear picture as possible as to what they've got to work with. And I think that's really important. Particularly once you start to get into a production phase of an operation, is that guiding your mining teams in these areas is really important to get confidence in your ability. Right, so we're going to be starting off by looking today at 3 data sets. So I've got a reverse circulation data set. That we're going to bring in. I think what's important to just chat about before we get started is that we're going to be looking at different data sets, and the purpose of this is to develop a geological model, so or geological wireframe. So the more data you have, the better you're going to be able to interpret that. So in this case, I've created these RC holes. They've been surveyed downhole, nice and straight. As you can see, I've given them quite a nice thick trace because that's generally RC holes are quite large holes. And you'll see that there's assay data at every meter interval. Well, we've also got a surface diamond drill hole set of data that correlates with that. And again, I've tried to make them a little bit sort of descriptive in that I've made the traces a little bit thinner, and the actual assaying or sampling data is just generally confined to the areas where there's actually mineralization downhole. As you'll see, these are all mostly incline holes because the structure is narrowvane and it's horizontal. It's a vertical narrowvane. Okay, so I've created a combined database using both sets of RC and diamond drill holes. I just wait for it to load there quick. Okay, so in these databases, what's important to note is that I've created the normal traditional survey, assay, lithology tables, but in addition, we've added another table which I've called strat, which is for the actual zones of mineralization that we're going to look at, and that allows you to extract that. So that's just a very simple table. It's got the borehole, it's got from, to, and then the zone that you are looking at. Okay, so if we take a look at the drill hole visualization tool, it allows us to play around with our assays values. We can have a label in that case. I've got the lithologies at this point in time loaded out. But what we're going to do is we're going to go look at the strat. So we've got combined reef is the actual table, and in there is a column called strat, and we're going to apply that to these boreholes. Right, so as you can see in the background there, it's now starting to change the traces. The traces become nice and thin, just to show where the drill holes are going. And as it's busy changing, you'll see that the actual zones of mineralization are now highlighted. So we'll zoom in there. Just give it a second to load. All right. Right, so there we have diamond drill 37, and right next to it you can see there's a gray zone. That's the deflection that's been drilled next to it. So very often this is a gold deposit that we're looking at, or an example of a gold deposit, and the deflection that's found next to it is there to confirm. Right, so we can, by right-clicking edit, we can then go in and edit those zones that we currently have. So there's two ways of doing that. You can manually do it, or there's you can also, by clicking on the little hand, you can come up and you can then toggle that. So if, for example, you drill a deflection and the deflection shows mineralization much wider, you can then make the mineralization in your main hole, your mother hole, actually match that deflection very simply by toggling that. You'll also see there's a set of handlebars about halfway down, which can be used for moving the mineral, the sort of whole mineral zone up and down the hole. And once you've done that, you can then click apply. We're just going to cancel this for now. Right, so as you can see, that hole's been selected, so it's bright, and you can see the assay data on it. The other ones are all grayed out. And then if I go and click on the actual database, it then highlights all the relevant holes again. Right, so in this example, we're going to look at the Narrowvane tool. I'm using the RC data because it's a small database, so it runs nice and quickly for the webinar. You can see that in this case, I've highlighted the zone. So in this case, in the Narrowvane tool, I've separated them out into the shears, which are what we were mapping. We'll look into model. What's important to note is they're coming towards the sort of western side here. There's a couple of holes that don't necessarily look 100% right. They don't match up with the other holes in terms of, so again, I can, if I go and click on center of rotation, I can move it around and have a look to see where they are. And I see that's not 100% right in RC49, so I can right click on it. I go edit. It gives me the option to manually edit it, but I'm going to do this using the slider or the toggling tool, and there I grab the handlebars and I can drag it down. So I'm saying, well, this is not potentially the top zone of mineralization, but possibly the bottom on top zone of mineralization. Now, on the right-hand side, you'll see that it gives you your actual measurements and tells you what the changes are. So you can extend that fairly accurately in this case and click OK, and then that zone is then being moved to the bottom of the hole from the top of the hole. So instead of actually having to go back and manually edit all these things. Also, if you take a look here, something strange seems to be happening because I've got two boreholes that are running parallel or sort of sub-parallel to each other, and there's mineralization in both of them that don't really match the the horizontal, at least the vertical nature of the ore body. Right, so let's run this and see what comes out. So what we do is we add the RC drilling base to the Narrowvane tool. You've also got the option, okay, right. So then we're going to pick the main shear zone. So you'll see I've got footwall, hanging wall. We've then got hanging wall data that we can then put in. So these could be CAD strings in order to help control for mapping. We can also relimit this to a polygon function. On our outputs, we're going to pick a vein solid. We're going to pick a hanging wall solid, footwall surface, and the data points for which the pinpricks where the boreholes actually intersect the actual solid. I'm going to say insert. It's also important to note there's a mid surface, which is a similar type of tool, which creates just a surface in between the intersection, which is very handy for generating things like faults, etc. Right. We've now generated our solid. And as you can see, as predicted, on the western side of the ore body over there, you've got a flattening out, almost like a hammerheading of the mineralization it does, which is not consistent with what we know geologically. So that's a problem. And that could be potential horsetaling, or if you take a look there, you'll see there's very few boreholes. So let's run that again. Right, so we don't want the actual database as a whole. Now what we can do is we can then add the boreholes. And what we're going to do is we can then just sort through these boreholes quickly. And we can take out 49. We're going to take out 59, 58. We've got 57s coming out, and then 65. So what will happen now is it'll actually ignore that data for now, and we can then focus on adding more interpretation. Same outputs, the surfaces and the points, and we're going to hit apply. And I'll explain to you a little bit later. In this case, we're going to hit replace. We're going to replace it. Why the points are important. Right, and there you'll see that you've generated the solid and it's excluded those boreholes on the end that need either more drilling or more geological interpretation. You also notice that on the solid, it's kind of got like a bit of a metallic texture. That's because there's a hanging wall and a footwall surface, as well as the drill holes that are all included. It's one output that's come out, but you can sort through that. So we'll look at that now quickly. So if we come through to your GeoModel container here, you'll see that underneath that we've got the solid. You've got a hanging wall surface, a footwall surface being generated, and the actual points of where the drill holes intersect the solid. Right, so this is a solid that I've now generated in its entirety. I'm going to change my center of rotation so it's easy to take a look at. And what we're going to look at is just editing these and easy edits that can allow you to quickly produce a finished result. So as you can see in this case, I've put the mine topper on, and unfortunately there's a little bit, because you've interpreted a little bit past that point, there's a little bit sticking out. So in the combination surface tool, we can then go and we can say solid and topography, and we're going to keep the actual solid below. So I'm going to select the actual zone I want to trim and the topography, and I'm going to hit apply. And what that's going to do is that's going to create a new solid, which is then trimmed to the topography. So there you've got it. Just select it. So it then goes into your surfaces container, and you've now got a solid that is neatly trimmed to the topography of your mine site. So I'll just turn on the drill holes, and then you can see that that correlates quite nicely with the surface there. Right, the other thing that we can look at doing is also bringing in potential mine site data. So in this case, this is a SRTM or shuttle radar telemetry mission data of 30 meters, which has been brought in as points. So very simply, when you're starting off on an exploration project or on a new mine site, you may not have topography yet. It's pretty quick and simple to get. So I'm just going to, in this case, trim it up nice and neatly. So I'm going to put a polygon around it. As you'll see, if the polygon runs over an actual data point, it goes red. I'll just move the spacer here quickly. Right, so click on that. And that allows me to give sort of a bounding polygon, which can be used to just trim it up and make it neat. Close the polygon. Right. So there we go. There's a polygon around the outside. And if I go surface topographic triangulation, I can then say relimit to polygon. And in my CAD folder, there's a polygon I just created. So I can actually generate or use that for clipping it. I hit apply, and there's my surface that's been trimmed up, ready for you to use for your exploration or mine site. Now, obviously, these surfaces have other important things that they can be used for. So part of that would also be draping data over the top of that surface. Right, so here we go. Here's the same topo, and I've actually draped some geophysics data, some mag data over the top, and it's showing multiple structures there. So again, going back to what we were talking about earlier, is collecting data from different sources. Very simply, I can now go and add some mapping data. So I'm just going to draw some very rough contacts in here. So the hanging wall contact there, or footwall contact, sorry.
So Mark, just while you're going through that process, this data that we're looking at here is an image that's been georeferenced, correct? As opposed
Correct,
to,
yes.
well, you could have used a database XYZ attribute for that data if you had that available as well.
Correct, yes. So there's again, could have been the geochemistry that you could have been using, that soil samples or RAB samples that you're using that have been generated. Right, so we just quickly outline that. Right, and then very simply, if I go down to my CAD section, I can then just go and edit those. And I can say footwall contact. I'll just make it a little bit shorter. And I've then got that for reference for actually putting into the Narrowvane tool, as I showed you before, which can then be used for actually modeling or adding to your modeling process. Also, what's important to notice is that some projects that you're going to get to are going to be slightly more brownfields. There's going to be data. So in this case, I've just generated or created the example of an exploration drive. So that could be something that has historically been put in. We used to see them quite a lot in Southern Africa in the sort of Victorian type setting. You could also have more traditional mining that's taken place. And those data sets can be brought in, mapping from that can be brought in order to help improve and enhance what you are actually using to map your again, very often if areas have been mined, there will be stoping or historic. So there's an example of a stope that's potentially been brought, which can then be used. You can have a hanging wall and a footwall contact of that stoped area to help enhance your modeling. Okay, the other thing that I'm very fond of is trenching, because it gives you a really nice starting point. It's a very cost-effective way of getting good geological data. So here I've got the trenches outlined. These can be picked up just toes and crests by a surveyor or scanned in using a LiDAR scanner. And you can then generate a 3D picture of those trenches, and mapping can be extracted from that in order to enhance your model from the surface down. Right, so what we're going to do now is we're going to look at extracting data out of, and some interpretation. So what we're going to look now is looking at pay shoots. So pay shoots are quite important. So I'm going to open up a hanging wall and a footwall surface that we generated out of our Narrowvane modeling tool. And as you can see, there's the data points. If I press the plus key, that increases the size of the data points where the boreholes intersect the solid. If I press the minus key, it reduces them. I can also export these. So for those of you that work in horizontal Narrowvane deposit, quite important for drill spacing, etc. And this can then be passed on to your, drafting department CAD guys, and they can then help you produce a very quick vertical projection. So what we're going to do is we're going to use the distance from object tool. So I'm going to select the hanging wall and footwall surfaces and chuck them into the container there. And as you can see, I've got that set out. I've got 1 meter, 2.5 meters. There's also an option between signed and absolute, just so that you understand that. Signed would be, for example, looking at movement. So it would be a positive and a negative, whereas absolute would be from a specific point going forward. And you can create contours and create a legend as well. So in this case, I've got 1 meter, 2.5 meters. I'm going to change that to 5, so it's very easy to edit. Or I can delete and change the intervals, add to them. So you can right click and go new. So just to explain the intervals here while I'm changing it back, 1 meter would sort of be the limit. 2.5 is conventional mining methods. 4.5 mechanized, and then 10 meters would be sort of an optimal size of Narrowvane. I'm going to select the two objects and I'm going to hit apply. And as you can see, it's now changed the color on the surface, and it's actually contoured it so that you've got the areas that are thick or more than 10 meters are now red, and the areas that are narrower than that. So there's nothing that's sort of 1 meter, everything's 2.5 meters plus, but there are some nice patchy zones there. And as you can see on the western side, you've got a nice fat. But what's important is if I add the drill holes here now to this to the picture, you can clearly see. Let's just give them a second to load. That you got a bit of an ore shoot there, but there's a lack of drilling below it. So that could account for why that ore shoot isn't extending down. You also potentially got another one to the east, and that would potentially have one pinching out and another one coming in, and that's important information. So as a geologist, that then gives you an indication of where you potentially need to focus a drilling program, and it also helps you with things like proposals. You can also extract or export contours of these areas, and these can be again exported very simply as a DXF for other CAD operations, etc. But you may also want to just change it up a bit and change the color. So in this case, we've got green. I can then go change it, make it a nice blue color. Right, there we go. And you can now have a bit of a contrast, and you can actually see the contours. Right, the other thing we're going to look at is drill spacing. So you use the same tool. So we're going to open up a copy of your main shear, the surface. And this time I'm going to actually open up the drill holes, the points that have come, that we've exported. So again, I can increase the size so I can see them nicely. So what we're looking at is how far apart on the vertical plane these drill holes are. So in this case, we're going to change up the scale that we've got. So, and because we're looking at trying to highlight the areas that where the drill holes are sort of optimal and not optimal, we're going to change the colors up a bit. So it's very simple. You just click on it. It gives you a color tablet or palette, and you can then change those out. So in this case, for this example, 12.5 meters is the sort of optimal, or the desired drill spacing to guide mining. Right, so 25 meters is what's required in order to develop a confidence in the resource, and 50 meters looking for continuity, etc. Right, so we just delete these guys out. Right, so we've got a reverse color palette there that we're going to use. So we can highlight it, and we're going to add in both of the data sets. Okay, so before I run this, I think what I'm going to do is I'm going to add an extra one in here, and I'm going to make this one 50 meters, which is a sort of optimal spacing, and then we'll make 100 meters, which is sort of regional, looking at regional data, but obviously that's all green, so let's just change that out and put a little bit of sort of neon blue in there. And then we're going to hit apply. Right, there we go. So there we have an outline of where all your drill spacing is. And you can see where the drill holes are closely spaced, they're all red, and where they're widely spaced, there's green in between, and where you've got very wide spacing, you then got blue spacing in between. So it just makes it nice and visual. Again, when you're trying to motivate, so what I'm going to do now is just start adding in polygons just to highlight these areas. And this again can be used in as part of your resource statements, etc. You can show where you've got confidence, etc. You can put a polygon around them. Obviously, this has just been done on very quickly and the rough and ready, and it depends on each separate ore body as to how you go about doing this, but it just helps this process along. So you can look at sample spacing, and that will then show you where you've got large sample spaces. Those can then be cropped out using those polygons, and then can then use those volumes to put into your resource and reserve statements.
So on that, Mark, just as a quick aside, when you're looking at those drill hole spacings, if you were to wanting to plan drilling projects going forward or to extend the resource, that could be a really good opportunity for something like a drill hole optimizer or a drill hole planner. I mean, how useful would that be for you in this kind of project?
Oh, very, very useful. I think it's definitely something. Right. So let's take a look at the multiple sort of shear. So in this case, what's important is that, as I said before, they sometimes come together and pull apart. So what I've done is I've edited the sort of hanging wall shear and made it so that it comes into the main shear. And the reason for this is that it's often an issue in terms of stuff. So I've got the surfaces, I've got another surface, which is a hanging wall surface, and I'm now going to use that again to crop the actual solid of the hanging wall. So I'm going to say keep above because it's stratigraphically above. I'm going to select the actual hanging wall surface that you want to trim up, and then use the hanging wall surface from your main zone in order to trim it. So I'm going to click on that, and that then very neatly trims that out for you. Okay, so the most important thing is this viable. So just take a look at it quickly around, and then if I right click on it and go to edit, I can then go to close to check, and you'll see at the bottom there it's a closed solid, so that can then be used to separate or domain out the additional zone that you're busy mining. Right. The other thing that we're going to look at is generating sections, which is and level planes, which or flitch planes, which is for me is a must. You know, you need those for your day-to-day work. So we're going to create parallel sections. It's very simple. You just click and drag it across, and that creates sections through the actual surface that you've. In this case, they're at 270 meters, or 227 meters, sorry. So we're going to make them 25. That's a bit too far apart, and you'll see that it changes. You can also merge them or flatten them for output for CAD, which makes is for actually doing paper-based sections, etc. to work on. You're going to then hit apply, and you'll see that it's then generated those sections for you at 25 meter spacing. So if I turn the solid off, just highlight that, it goes into the contour container. You can see very clearly that you've got some nice looking sections that have come out of that. So let's look at these in a bit more detail. So let's just open these sections up. Let's just open up the first couple. Right. So as you can see from this, you're getting a lovely organic set of sections which are being produced. And again, I can very quickly export those as a DXF. To be used elsewhere. But the most important thing is that they're nice and organic, and that they're not that blocky output that historically you get. Right. The other option is level planes, and I'm going to give two examples here. So the first one, let's generate some level planes. So again, surface, parallel sections. We'll go from the bottom up. Again, distance is a bit thing, but we need to say make sections vertical, turn that off. And at the moment, 72 meters. So I'm going to make it 30 meters or 100 feet, which is a sort of traditional distance. It may depend on the mining operation you're on. You can change that. And there we go. So it's now created flat sections or horizontal sections that can then be used. So these can then be outputted into plans, etc., which can help you with guiding the mining. So we've taken this lot. This is just the main structure, but in this example, we've generated two structures that we're busy looking at. So, right. So let's open up the other structure, which is the hanging wall structure that we've got. We're going to create parallel sections again. Again, change those to 30 meters. A bit too far apart. And you're going to apply. Right. turn that off. And we're going to change the color of the actual hanging wall sections and make them a nice bright pink. Turn the surface off. Right, so there we go. So there we've got both the hanging wall and footwall sections running, and they're able to be used for guiding your mining teams, etc. So just turn these guys off. We're going to turn on one. Right, just to bear in mind that obviously the sections are generated from where you click first. So in this case, section 1 will be so we've generated them from the bottom up. You can do it the other way around if that's what you prefer. So there we go. There's a hanging wall and footwall structures that are now available for you to chuck out. So let's do that quickly. So let's select the other section. If I select them both, I can then export those, and they've been chucked out as a DXF, which can then be brought in on a level plan, and that can be used to help mine your guide your mining teams.
Thanks a lot, Mark. The first question I have is just to get an understanding of the time that was involved in you making this this model versus how your experience doing the same model in the field all those years ago without this technology.
Yeah, I think the traditional method would have been to generate the sections and then use a tie line to bring them together. And to update that would have taken the better part of a week. So once you've got a bit of experience and a bit of an understanding of the ore body, it would take at least a week in order to update that and then regenerate a new solid. For me, where I saw, I got really excited about this was the fact that you could literally do this on a weekly basis. As your data is coming in from your section geologists, from your mine geologists, you can update the information that you've got available to you, and you can then generate a fresh solid or wireframe that can be then used to help with your guiding of your mining teams, etc., and improve the confidence in you as a geological team going forward, which is for me is really exciting.
So to generate the surface and even those heat maps of the drill hole spacing, that whole process, if your data was ready, is maybe what, an hour or?
Yeah. I think it probably took me about a day to generate the solid, to tweak the data. Obviously once you've got a handle on that, I'd say probably 2 days in total, if you're starting from fresh and you're looking at fresh data.
And we looked at that through a pretty, what we'd probably say in the software world, quite a manual process still. We've helped some of our customers set up a workflow. So for those who are familiar with the workflows, you might understand what I'm talking about. For those who are not, we'll talk about that at another point. But you could automate that through a workflow, right?
Oh, without question. I mean, I obviously didn't delve into that in too much detail because each mine site's got its own individual processes that it follows. So it's slightly different on each mine site, even in the same type of resource. But without question, once you've got your sort of day-to-day structure sorted out, those processes can be very quickly automated. So going from taking your solid all the way through to putting out your heat maps and then your spotty map showing your drill spacing could literally be one process. So it could be sort of a 10, 15 minute run and you're done and dusted.
And you talked about exporting the data that you created to DXF, but a lot of the people that are on this webinar probably use Vulkan already. So this data is perfectly interchangeable with Vulkan within that Maptek ecospace.
Yes. So it can be opened up in through the workbench in any of the other applications really quickly and easily. So that makes it really powerful and easy workflow.
So just another question coming just as I was about to finish. What are the benefits to using the tools here in Eureka compared to doing this kind of model in Vulkan?
The Narrowvane modeling tool is now available in Vulkan. So it would also be available in Vulkan. I think from Eureka's perspective, it's, and without getting too too far down on the sales side, is obviously a cheap, very powerful, cost-effective way of enabling your team to have access to the resources that are to generate this stuff. So, yeah, I mean, that would be the difference there, I would say. But it is available in Vulkan now, so it's there for you to use.
Thanks, Mark. What we'll do now is we'll just finish up this Q&A session. If anyone's got any other questions that they'd like to ask at any point, just send them through to us. You can see our contact details on the screen, or contact your local Maptek office, and someone can try and help you out. We hope that you enjoyed the webinar today. As we mentioned at the start, we've done quite a lot of webinars recently around this topic and other topics. So if you want to see any of those, please go to our website and go to the resources tab, where you'll be able to see the rest of the webinars. If you get a moment, can you please take the opportunity just to answer the poll that's appeared on your screen just now? Just to help us understand how we can present things to you that are going to be engaging and interesting and educational for you. Now, the actual recording of this webinar should be available later this week or perhaps next week. Once we get it ready, you'll automatically receive a link so that you can watch it on demand, and you can share it with colleagues within your organization. So for those who have not been able to attend, they can watch that in their own time. Now, of course, if you'd like someone at Maptek to get in touch with you about this or about anything else that we've covered, please feel free to get in touch with us. You can see email addresses for Mark and myself on the screen today. And like I say, you can visit the website to find contact details for your local office. So thanks again for everyone who's taken the time to join today. Please have a safe and enjoyable the rest of your day. And we look forward to seeing you at some point in the future. Thank you.